Welcome to Susan and John MathTube. In this video, we're going to learn diagonalization using orthogonal transformation. Without this information, you will not be able to understand quadratic forms properly. Come on, you might be wondering why you need this method for diagonalization. Look at this. In the last three videos, we learned the theory, the application, and how to diagonalize 2 by 2 and 3 by 3 matrices. But if you look at those problems, the most toughest part will be evaluation of M inverse. Now, suppose the given matrix is symmetric. What do you mean by symmetric? You read any matrix row by row and write it column by column. Then if you see that both are same, that is, if you transpose a matrix and you find that it is the same as the given matrix, that is called a symmetric matrix. What do you call it? Symmetrics. And only for symmetric matrix we can use the orthogonal transformation. And the most beautiful thing about this orthogonal transformation is you don't have to evaluate the inverse. Okay, so the process goes something very similar. Find the characteristic equation, find eigenvalue eigenvector, and augment the eigenvectors model matrix. Now it's different. Now instead of finding M inverse, you'll find another character called the normalized matrix. And how do you normalize? You find unit eigenvectors. I think you remember, if you have a vector 1, 2, 3, you find the modulus. What's the modulus of this vector? 1 square plus 2 square plus 3 square. The modulus, the length of the vector. And that turns out to be 1 plus 9, 10, 14. So the unit vector will be 1 by root 14, 2 by root 14, 3 by root 14. So did you get the point? Instead of using M inverse AM, we are going to use N transpose. Come on, taking transpose means just interchange the row with column or column with row. Isn't it easy? And we get a relation like this. So like I told you before, as a mathematician, my job is to tell you, if you have a symmetric matrix, not any matrix, if you have a symmetric matrix, then N transpose AN is equal to D. By the way, don't forget, get connected with us, Facebook or Insta. Okay, so please write, diagonalize the matrix 5, 2, 2, 2. Okay, now look at this. This is a symmetric matrix. Okay, so we have A transpose equal to A. Read downwards, write sidewards. Read sidewards, write downwards. You'll get this. Now, if you have a symmetric matrix, you have two methods. One is, of course, our old method M inverse AM, and the new method N transpose AN. And we will use this method here. So what is step number 1? Of course, characteristic equation. And I'll write it directly, lambda square minus 7 lambda plus 6 equal to 0. And I got the eigenvalues 1 and 6. And I found the eigenvectors. And the eigenvectors turned out to be, come on, pause the video, try it. If you are not able to work out this problem, then it means you have some serious trouble in eigenvalues, eigenvectors. Anyway, I got 1 minus 2 multiplied by t. Don't get worried if you get minus 1, 2. It will be some multiple. And I got the eigenvector x2 is equal to 2, 1 multiplied by t. I'm going to convert this into n. How do you write n? You have to make it unit vector. So the modulus of the first column will be 1 plus 4, that will be root 5. So I get 1 by root 5 minus 2 by root 5, and yeah, same thing, 2 by root 5, 1 by root 5. If you want, you can take common, but generally you may not be able to take common. Okay, now what's the formula? N transpose An. Look, it's so easy to write the transpose. 1 by root 5. I'm writing it row wise, so I have to read column wise. Root 5 and 2 by root 5, 1 by root 5 multiplied by the given matrix 5, 2, 2, 2, and multiplied by n 1 by root 5, 2 by root 5 minus 2 by root 5, 1 by root 5. Plug this into a calculator. Guaranteed you will get, come on, can you tell me what will you get? 1006. If you are not getting this answer, then something went wrong. Okay, let's do one 3 by 3 and wind it up, and we are ready for quadratic form. Okay, so please write the second question. Diagonalize. Once more, let me advise you, pause the video, use this as an opportunity to make your eigenvalues and eigenvectors perfect. So diagonalize 2, 1, minus 1, 1, 1, minus 2, minus 1, minus 2, 1. Once more, I'm telling you, work out step by step, because I'm going to keep the same problem in quadratic form. You'll remember this problem in quadratic form. Okay, you pause the video, I'll write the solution here. Look at this. A transpose is equal to A. Can you see that? You read downwards, or you just draw a line in the leading diagonal, you'll see the reflection. So I have two methods. Of course, the first method will work, M inverse AM. But we have an easier method, that is N transpose AN. Okay, so we go for it. S1, S2, S3. I'll tell you the values. You can check it later. And if you made any mistake, correct it. 4, minus 1 and minus 4. Lambda cube minus 4 lambda square minus lambda plus 4 equal to 0. And the eigenvalues turned out to be minus 1, 1, 4. And the eigenvectors are x1. I got 0, 1, 1. Double check it. x2. I got 2, minus 1, 1. And x3 is 1, 1, minus 1. Comment below whether you are able to solve it smoothly or not. And tell me whether you got the same answers or not. It'll be nice if you comment below. Okay, now what should we do? M. How do you write M? Augment them. So it'll be like 0, 1, 1, 2, minus 1, 1, 1, 1, minus 1. And then we write n. Can you tell me n? Yeah, normalize. So 0 by root 2, 1 by root 2, 1 by root 2. How did I get root 2? Root under 0 square plus 1 square plus 1 square. So 2 divided by, come on, 4 plus 1 plus 1, root 6 minus 1 by root 6, 1 by root 6. 1 by root 3, 1 by root 3, 1 by root 3. See? And all you have to do is you write N transpose AN, take a calculator, try it, and if you do not get minus 1, 0, 0, 0, 1, 0, 0, 0, 4, something is wrong. And once more, as a mathematician, my job is to convince you that N transpose AN will be the diagonal matrix which contains the eigenvalues. So I'll be back with quadratic form. So till then, my friends,